This question appeared as a 3-mark question in 2017 CBSE 10th standard board exam. The equation actually looks a bit daunting to start with. The roots of the equation a square plus b square x square minus 2 times of ac plus bdx plus c square plus d square equals 0 are equal. The roots of this big equation are equal. What we need to prove is a by b equals c by d. What does this equation look like? It's got an x square term, it's got an x term, and it's got a constant. So this obviously is a quadratic equation. The roots of this equation are equal. For any quadratic equation, the generalized form px square plus qx plus r equals 0, the roots will be equal and real when its discriminant is equal to 0. The discriminant of a quadratic equation for an ax square plus bx plus c would have been b square minus 4ac. I've just used these as a coefficients so that we don't confuse with these abcds. So it's going to be q square minus 4pr should be equal to 0 for the roots to be equal. What is p for us? A square plus b square. What is q? Minus 2 times of ac plus bd. And what is r? C square plus d square. So we got all these terms. So all that we are going to do is basically plug in these values into this discriminant, equate it to 0 and check whether that translates to what we need to prove. Let's do that and figure out whether it works out that way. So our p is equal to a square plus b square, q equals this, r equals this. So we need to make q square minus 4pr to be equal to 0, which essentially is q square is a minus 2 into ac plus bd, this entire term, the whole square, minus 4 into p is nothing but a square plus b square, and r is nothing but c square plus d square. Let's square this term, which is 4 into is of the form x plus y the whole square, which is x square, a square, c square, plus y square, which is b square, d square, plus 2x into y, which is 2 into ac into bd, we'll write it as a, b, c, d, minus 4 into a square, c square, plus a square, d square, plus b square, c square, plus b square, d square. So this is what we have. The a square, c square, 4a square, c square, and minus 4a square, c square, these two terms will get cancelled. 4b square, d square will get cancelled with this 4b square, d square. So what we are left with is 8abcd, 4 into 2 into abcd, minus 4a square, d square, minus 4b square, c square equals 0 is what we have, right? The discriminant should be equal to 0. What we'll do is we'll divide this entire equation by a minus 4. So we'll have a square, d square, plus b square, c square, minus of 2abcd. Think of this term as an x square term. Think of this part as a y square term. So this is going to be 2 times of x into y. X square plus y square minus 2xy is nothing but x minus y the whole square. So this entire term is equal to ad minus bc the whole square, which is equal to 0. Which means ad minus bc equal to 0. Translates to the fact that ad is equal to bc. Get the b to the denominator on the left hand side, d to the denominator on the right hand side. So you get a by b is equal to c by d, which is what we set about proving initially. Quickly run through this entire exercise of solving this discriminant equation in a printed form in the next slide. So this is q square minus 4 into p into r. Expand this term, so you'll get something like 4a square, c square plus all of these terms that you got. Let's cancel out like terms which are in opposite signs. So these two get cancelled. These two values also get cancelled. So what we are left with is 4a square d square plus 4b square c square minus 8abcd equals 0. Divide by a 4. So this is the equation that you're going to see. There's nothing but ad minus bc the whole square, translating to ad equals bc, or a by b is equal to c by d.